Right, in this video I'm going to talk about running issues you might experience, the sensors that you might want to have a look at and their function, as well as some of the symptoms you might experience if they're starting to go wrong. So this is a Mercedes 190 2.5 16 valve, and it has the K-Jetronic CIS-E that it uses for the injection system. The 2.3 16 valve also will have a very similar setup in terms of the sensors and relays, parts that contribute to the running of the engine. Some sensors are also shared on the other variants, the 2 litre, the 1.8, or even the 2.6. But yeah, let's run through some of the sensors, because when I first started out on this platform, it was quite difficult for me to find information. I had to do some research on the sensors, on how they functioned, and it was a bit of a lengthy process because a lot of acronyms are used on forums. So I'll at least point out where in the engine bay you'll find certain sensors. So let's start at the front of the engine, I suppose. So this isn't associated to the running, but people often don't know what this piece actually is. This is the hydraulic pump, and it uses hydraulic fluid from there to either lock the rear differential above certain speed if your car has ASD, and it's also used for the self-leveling suspension on the rear. So if the car had load in it, the suspension would sense that it's sitting lower than it should be based on a lever system, and it would automatically pump the shocks up to bring the level back to the correct ride height. So that's what that piece is. This one here is for your temperature gauge on your clocks inside. So it'll be the coolant temperature, which is there on the left. So that's what that is. The one in the middle, this is your coolant temperature sensor. So this is what tells the ECU where the temperature is at, and you can see it's got 4 pins. So to check that it's actually working correctly, you can check the resistance between the 2 diagonal pins like that, to see whether it's within the correct parameters, and depending on the temperature of the car, it should vary. And then this one here is, that one there is for your fan. So once it hits around 90 degrees, it will kick the electromagnetic switch in on here, if you've got the original fan, whereas on mine someone swapped that out, so instead it activates this electronic one here. Here you have your injectors. These injector lines come out of there. Down here you have your fuel pressure regulator. Okay. Here we have the cold start valve, and it's got this blue plug, and this is in charge of chucking a bit of extra fuel in when the car's cold. So you can see maybe just about, there's a fuel hose going in there. It's a metal hose which comes out from there. Okay, and that is actually linked up to the idle control valve down here, and that chucks in extra air on idle to make sure you've got a level idle. Some of these components are going to be quite difficult to show. There's also the throttle position sensor, which sits on the side of the throttle body, but the plug for it is just there, and again it's a 3-pin plug, and there's some details in the workshop manual on how to test the function of that. It's essentially moving this this linkage here, and the resistance will vary on that 3-pin plug, so you can check that again it's running as it should. This is a throttle position sensor, and as you can see, quite simple. When you let go of the accelerator, it clicks onto that, and there's a plug underneath. This will usually mess with your idle, because the car will think, oh, it's not on the stop there, so the idle might be all over the place. Sorry, this one's a throttle body position sensor down there. That's the plug for it, and it actually sits under a rubber boot from this air box. Okay, so that's that. Then around here we've got, this is the EHA valve, and this actually enriches the fuel going into the engine at certain running conditions, when you're at high revs, or even at idle, and if you've got some flat spots that you're noticing through the rev range, it might be a case of either this leaking in some way, or it might need some adjustment. What you would need to do is take off these two there, and then on the other side of this, where it mates up with this main gauge electronic unit, there's an Allen key adjustment. Then here, this one going into the air box, this is an air temperature sensor. This plug down here is actually for the idle control valve. So again, you can check on the connection there what the values are. I'll just check what this sensor is, and I'll check what this sensor is. The other thing to be aware of is vacuum leaks, which you'll find on the hoses around the air control valve, idle control valve, which actually goes down there. As you can probably imagine, it gets quite hot around here. The rubber just gets brittle over age, hardens and then cracks. Same with the rubber boot that goes to the throttle body underneath this air box. You can get leaks there. And then obviously all of these little vacuum hoses I'd have a look at, just to make sure you're not getting leaks anywhere. So this is the EZL unit that controls the ignition, and then there's vacuum hoses going all sorts of places. The other thing I can show you is this diagnostic plug, which if your car has a lambda sensor, you can actually use that port for checking the duty cycle, to see what is going on there. You've also got here, this one under there this is for your ASD, as it says in big letters. So that controls the locking diff on the back. I forgot to mention the 8-pin plug just there for diagnostics that sits in front of the battery. You can test the ASD and the injection system as well. This plug I showed, I don't think you can generally find code readers for these. Same for that one. You need a little LED tester, which you can actually create yourself. It's just a bit of wiring and a switch, and it will blink the error codes if there are any. Right, back to it. Behind the battery, you're going to have two relays. So there's one that's got like a red top. It's even behind the ECU, about where I'm pointing. Usually there's a cover here. Mine's missing at the moment. And near it you'll have a black relay. That is your fuel pump relay, and the red one is your OVP relay. Now the fuel pump relay will obviously affect the fuel pump actually turning on. It controls the cold start valve, and it can affect the running of the car as well, obviously. So the fuel pump relay is a good one to check. You can slice it open with a butter knife, and you can take out the board and you can visually inspect it. I'd be looking for dry solder joints, because they can cause all sorts of issues. And it's a relatively easy fix, so it doesn't hurt to do that at all. Same with the OVP relay. There is a way to actually test that on a few different pins, but again, there's two fuses under a little flip cover, which you should check, because again, that'll mean that certain things stop functioning, such as a cold start valve, and obviously then you'll have cold starting issues. And you know, I've showed you some connectors and plugs, so you can check with a multimeter whether they're getting power, or you know, whatever resistance should be there on this one, for example, on the coolant temperature sensor. What else is there to check? I think those are the main ones really, which can affect the running of the car. Oh yeah, there's a potentiometer on the side of the... Oh, it's going to be so difficult to see, and but it's essentially down there. It's on the side of the unit with a plug going to it. It's kind of behind the cold start valve, and again, that gives an electrical signal as the airflow plate moves up and down. So if I just open this up, so as this airflow plate moves up and down, there's a sensor on the side with an electrical signal, which again, you'll end up with flat spots in your rev range, and that one is probably the one I'd try replace last. If you're going for an original one, it's quite expensive, and it's really fiddly to get to, because as you can see, you know, there's all of this in the way, so you have to move fuel hoses out the way, the cold start valve. You'll need to take this off, obviously, and then it's really fiddly setting it up, because you need to be looking at the resistance and making micro adjustments to make sure the resistance is at a certain level when the plate is in this position, and at another value as you move it around. So that one I'd probably replace last. But as you can see, there's a lot that goes into ensuring it's all set up correctly and the correct pressures are there at different temperatures, and so on. So I've been through this previously with my old car, and it's not a fun journey. The sensors, as you go through, add up in terms of cost, and it's great, once you get there. But in this day and age, we've got electronic fuel injection that we can do, and it'll just make it run, consistently and a lot better going forward. So that's the route I've chosen to go down, rather than trying to replace all of these sensors. Electronic fuel injection, if you're doing it on a budget, you can probably try get it done probably for about £1,000, and some of your time. I think that's what I remember budgeting for it, and that's with a DIY ECU, and sensors from other manufacturers which are readily available. For example, a camshaft sensor from a Honda Jazz to use with a trigger wheel, and a throttle position sensor, and that's just with a single intake. That's not individual throttle bodies, which is something I'd potentially do, but that adds another £250 for just the intake, and then a few £100 for the actual throttle bodies as well. Okay, so hopefully that gives you an idea of where certain sensors are, things to look out for in terms of if you're experiencing running issues. Like I said, I found it quite time consuming to figure out these certain things in terms of what they do, where they sit, how they function, and I thought it'd be a useful video to give you a quick introduction, so you can obviously go away and do your own research on some of the potential symptoms I've mentioned. I mean, the most common stuff is fuel pump relay, OVP relay. I've not really had the idle control valve go wrong. I have had the throttle body position sensor go wrong. I've had this throttle position sensor go wrong, sometimes referred to as a TPS. So the symptoms were the car was just revving wherever it wanted, and that's because it didn't know the position of where the throttle body, how far the butterfly was open. So I think it was just chucking extra fuel in, and then essentially the idle control valve was trying to compensate for that. So the idle was just up and down, up and down, up and down. And the other one is hot starting, which is usually temperature related. There might be a bit of vapor lock because of the heat soak that you get off the engine. What else have I had? I think those are the main bits, really. Those are the main issues I've had in terms of running. But I got to the point where I was just, slowly replacing all of the sensors just to get it running absolutely perfectly. And like I said, it costs a lot of money. It's not cheap. And with this example of car, I think it makes sense to not be bothered about keeping it too original. Anyway, I hope you found that useful. As mentioned, it was only a summary really to give you a bit of an overview. Obviously, you can go away and dig a bit deeper into each of those things. Right, until next time.